So good morning, everyone. So it was brought to my attention that the lesson yesterday for the linear regression was not very helpful for the lesson. I apologize about that. I am teaching 3 grade 12 courses this summer, so it's easy for little things like that to slip. And so I'm going to go through it today for you, as well as the linear regression lesson for today as well. So we're gonna kind of mix that up together, and you should be able to work on your practice questions a little bit better and understand it a little bit better. So I'm going to share my screen here for yesterday's lesson and make it bigger. And I am thinking that my tablet's finally going to work here. Hopefully everything went well. You do have your first quiz today, so keep that in mind. Hopefully everything is going pretty well. If you're having issues or have any feedback, I'm definitely open to that. This program is for you guys, not for me. Okay. So last lesson you learned that by examining a scatter plot, you can see whether the relationship between two variables is strong or weak, positive or negative, linear or nonlinear. So in this lesson, you will use technology that will allow you to quantify the linear correlation between two quantitative variables. So we're going to look at the correlation coefficient, so R, the coefficient of determination, which is R squared, regression line, which is Y equals A plus BX. So if you remember from like grade 9 and grade 10, you have the equation mx plus b, very, very similar. It is linear, right? And then your residual values. So to start off, we've got the correlation coefficient R. So the number R is a number between, I just need to get my stuff here, text. So between -1 and 1, that is an indicator of both the strength and the direction of a linear relationship between two quantitative variables. A value of R equals 0 indicates no correlation, while R equals 1 and R equals -1 indicate a perfect positive or negative correlation. So in other words, if it's negative, like if your line is going downwards, such as this one here, then it would be a negative. So it's between 0 and -1. So if you've got a weak correlation, it's -0.5. If it's moderate, it's between 0.5 and 0.8. And if it's strong, it's between 0.8 and 1. So I'm going to clear this and we'll move on to the next page. So the coefficient of determination R squared is a number between zero and 1 that is useful because it gives the proportion of the variance, so the fluctuation of one variable that is predictable from the other variable. Just give me a sec here. Okay, so sorry about that. So it's between 0 and 1 that is useful because it gives the proportion of the variance, so the fluctuation of one variable that is predictable from the other variable. It is a measure that allows us to determine how certain one can be in making predictions from a certain model or graph. So it really tells you on a scale from 0 to 1 How accurate is it? Can you make good predictions and move forward? So the coefficient of determination is a measure of how well the regression line, so the line of best fit, which is something you would have seen in grade 9 or 10, that represents the data. So if the regression line passes exactly through every point on the scatter plot, it would be able to explain all of the variations. So if you have a strong correlation, your line of best fit is going to very accurately follow that. So it's easy to predict. But if you have a weak correlation, your line's not going to hit as many points while you're doing it. And so your prediction's not going to be super great or super accurate. You're going to have to guess a lot. And that's where you might have different answers than I do. And that's okay, because it's really just kind of a guesstimate. Okay. So the further the line is away from the points, the less it is able to explain. So again, if your points are very far from that line of best fit, obviously it's going to be less accurate and able to give a prediction. So for example, if R is equal to 0.922, then R squared, which is your coefficient of determination, would be 0.850, which means that 85% of the total variation in Y can be explained by the linear relationship. Okay, so our coefficient of determination is our percentage of how accurate it's going to be. The other 15% of the total variation in Y remains unexplained. So hopefully that makes sense. So your correlation coefficient just tells you if it's strong, weak, moderate, positive, negative. So as we've seen before, and then your coefficient of determination, which is R squared, is going to tell you how good your prediction is going to be. That's the conclusion of those two first parts. So then I'm going to clear this, and we're going to go to the regression line, which is your line of best fit. So a regression line is a line that describes how a dependent variable Y changes as the independent variable X changes. We often use a regression line to predict the value of Y for a given value of X. So the equation is in your, I don't care for this one much. I would much rather Y equals mx plus b, because it's something that you're familiar with. And it's really just the same without that line in front of the b. So your m would be your slope. So is it going upwards? Is it going downwards? So that's your rise over your run. And then your b is your y-intercept. So if you're more familiar with this and you understand that more, ignore these things. And so I'm going to try drawing. Let's see if it works today. Okay. Yeah. So this is your slope, which is your rise over your run. This is your y-intercept. So that's where it crosses the y-axis. And this is your predicted value. I much prefer this than that. Like I said, it is something that you should be familiar with. You did a lot of it in grade 9. I think that would have been some of the main focus. Hopefully you remember it. So I'm going to clear this, and we're going to do some examples. So the equation of regression line for the scatter plot shown to the right is the price is equal to 38,257 minus 0.1629 times the miles driven. Identify the slope and y-intercept of the regression line. Okay, so in the equation for A, our slope, so slope is M. Oh, nice. I'm so happy this is working. So slope is M, which is that part right here. So in front of your times your dependent variable. So your slope is this. And it shows us that it is negative. And it is a weak correlation. Correlation. I'm just butchering this word. Anyways, you know what I mean. So it is also telling us that for each mile, so for each mile driven, it decreases by 629. Okay, and then our y-intercept, which is our B, is going to be 38,000. Okay, and that is this part right here. So you see how it's open for interpretation. They gave you the equation, but like honestly, I would have said it's 39,000 because I would have rounded, right? So it's open for interpretation. Obviously, as long as you're pretty close to the number, totally fine. So I'm going to clear this and we'll go to part 4. So we have the residual values. So a residual is the difference between an observed value of y and the value predicted by the regression line. Residual value tells us how far off the line regressions predict is at a given point. So in other words, you've got your line of best fit. You've got your points because your line of best fit is never going to fully touch all the points. So it's comparing where your dot actually is versus what your prediction is. So your line of best fit. So it's telling you the deviation, the difference in that. Okay, so when you do that, you do your observed y, which is your y value of your point that actually exists. And then your predicted y, so the y that's on your line. Okay, so using the regression equation from example 1, find and interpret the residual for a truck that had 70,583 miles driven and a price of 21,994. Just gonna drink a bit of my coffee here. Okay, so we're using the equation that they gave us above, which was y is equal to 38,257 minus 0.1629 times your predicted amount. So your predicted is this guy, so times 70,583 miles. Okay, so you throw that into the calculator and you're going to get 26,759. But for this truck, the actual price is 21,994. So you have to do your residual, which is your observed y minus your predicted y. Okay, so your observed Y is right here. And if you were to look here, it gives you this total amount. So 21,994. And your predicted is this guy. Throw that into the calculator. So this means that your dot is off by $4,765. It's too low, in other words. So hopefully that makes sense. So we're gonna write that down. So I'm gonna type it. This tells us that the actual point or actual price of this truck is 4,765 lower than expected based on its mileage. Okay. So in other words, your dot is $4,765 below your line of best fit. Okay. So note that if the regression model is a good fit, the residual should be fairly small and there should be no noticeable pattern. So large residual, such as our example here, or a noticeable pattern, are indicators that another model may be more appropriate. Okay, so I'm clearing this and we're off to example 3. So sketch the residual point of the following graph, comment about what it tells you. Okay. I'm gonna draw. Okay, so it is telling us that at 4, it is at what in the world? Oh, I see what it, okay. So meaning at 4, it's at 5. That goes there, that goes there. So essentially, we're taking this line of best fit and it's going fully horizontal and the points are following. So you can see that the points don't move, they go pretty well one by one. So it takes a bit of visualizing. Like that, and then like that. Okay. So the distinguishable pattern in the residual shows that a linear regression is not an appropriate regression model in this situation. Okay, so in other words, in a simpler way, your plots, your points are making a curve, so it's not linear. So you're not going to be able to do a line of best fit because it's not following the same pattern. So essentially it's just saying it's not appropriate, it doesn't work. Okay, that's really it. So I'm going to clear this. So here you've got phrases to use in your answers. So regression just means your interpretation in context of it's your predicted. Okay, your R is your positive or negative, weak or strong linear correlation between explanatory variable and response variable. R squared is your percentage of your approximate linear relationship. Your slope is just your rise over your run. Your y-intercept is where it crosses the y-axis. So these are words that should be familiar for you, hopefully. Okay, so you've got your independent work. So match each of the following scatter plots with the R below to describe it, and so on. So I'm going to move forward with today's lesson, wherever the heck it went here, right here. Okay. So a lot of that was using calculators. So I did remove quite a bit of that lesson from yesterday. Okay, so we've got today's. So like I said earlier, you've got quiz number 1 that's due today. So make sure that you're putting that in its own separate Dropbox file. So it should say quiz 1, and then your grades will be up on Edsby, or I'll write it in the comments of the LMS. If you ever get to a point where you're at a 60, I will let you know. I know a lot of you are from out of board and might not have access or know how to use Edsby. It's super useful. So that's where you would see your attendance. That's where you would see your marks if you have anything overdue, etc. Usually I do a check-in on Fridays. If I'm missing quite a bit, then I will send you an email with a list of work that needs to be completed and handed in. Okay, so the quiz isn't too long. I want to say it's out of 39 points. And so we're going to look at line regression by hand. Okay, so we have our MDM 4U marks that are given to us in here. At the very bottom, you've got your totals here. Okay, so you would calculate all of that up, and it would give you a nice total of 491. You've got your grade 12 average. So that would be, again, you're going to add up your totals, which would be 515. So your x squared here is just going to be this squared. So in other words, I'm going to use my drawing pen for this one. Okay, so this is 66 squared, which is going to be 4,356, sorry. 53 squared. So you just work through completing the table. 80 squared, which is going to give you 64,000 or 6,400. And you're going to total them all up to give you 36,091. You're going to do the same thing with your y values. So 77 squared is going to give you 5,929. 67 squared is going to give you 4,489. Okay. 7,225, and you're going to add them all up to get 38,637. This is your y, or your x times your y. So this times that. Okay, so you've got 74 times 77, which is going to be 5,698. You're going to have 45 times 55, which is 2,475, and 80 times 76, which is 6,080. And you're going to add up your totals, which is 37,159. Okay. So I'm going to clear this and we're going to move forward. That bit is a little bit easier. So determine the equation of the least squares regression line. So the line of best fit. So in other words, this is finding your slope. I definitely should have gave you guys. So you want to find your slope and then your y-intercept. And then put it in your y equals mx plus b. Okay, so your slope is going to be found by doing I'm just messing everything up over here. Okay. Okay, sorry there. Okay. So I'm going to move this. Okay, so your slope is found by, so your slope is your m or your b, depending which equation you're using. And you would find it by doing n times this guy, xy, minus y over okay, so you're gonna have to go back to your table here, but your n is the difference between your x's. So if we were to look at our graph or table, you would do your 74 minus your 81, which is 7. It'll be -7. So it goes up or down by 7 each time. So it's your difference between your x's, not the people you've dated. I had to say it. Okay, so I'm just going off of what we found in the table. You'll have to go back and look. Unfortunately, I can't go up by any means. Okay, your n is your 7. Okay, so these are all numbers that we found up there. 91, and then that'll be squared. So this gives us 0.6272. So that means that the model predicts a 0.6272% increase in overall grade 12 average. So I'm going to write that down. Indicates that for every 1% increase in the average, the model predicts a 0.6272% increase in overall grade 12 average. I'm gonna just fix this up real quick. Okay. So that's our slope. And then we've got to find our y-intercept. So our y-intercept, you have to find this over n. So this is 491 over 7, which is 70.14. If you throw it into the calculator, you will do the same thing to y, which is 515 over 7. And if you throw that into the calculator, you have 73.57. Okay. And so your y-intercept, you throw it into the calculator. So y is equal to b minus this is that value. And your x will be this value. And we know our m from up here. This is our m. Okay, so 73.57 minus 0.6272 times 70.14. And that'll give our y-intercept of 29.58. Okay. So in other words, our equation is 0.6272 x plus our y-intercept, which is 29.58. And that's it. That's our equation. Okay. And so now we're going to find our correlation. So I'm clearing this. I'll move down. I didn't really give myself much room for that. Actually, I can. Aha. Nice. Okay. So to find the correlation, that is our R. So we do N this value minus. So these are equations you're going to have to maybe write down. I would suggest doing it on a different sheet. That way you don't forget, right? So you've got quite a few formulas that were handed to you today. And x squared minus. So keep in mind that n is just taking your, we call it the first difference. Hopefully you remember that. So the first difference of your x values in your graph or in your table. So essentially, by how many units is your x going up? So it's not always going to be, this is a disaster looking. It's not always going to be 1, right? It's not going up by 1 every time. And so the difference is going to be a little bit different every time. Okay, so our difference is 7. We've got these guys here. Throw it into the calculator. 491, 115 over the square root of 7. So you should notice that the answer keys have been put up. So our correlation is 0.93196. If you were to throw that into the calculator. So this indicates that there is a strong positive linear correlation between data grades, and overall grade 12 average. So if you were to square this part, it's going to tell us that approximately 86.86% of the variation in grade 12 can be explained. Okay, so I'm gonna clear that. I'm gonna do the next lesson. Hopefully this makes sense to you. If you have any issues, just let me know. I am open on Microsoft Teams. I know some of you might have issues with it. And so you can email me. Just don't, I'm asking you not to message me on the LMS, just because I don't get emails for that. So unless I'm opening LMS, which I only open it twice a day to put your work on and to look at the Dropbox at the end of the day, I don't see those messages, right? So just either email me or message me on Microsoft Teams. Okay, and that's it. Good luck.